Imagine a point infinitely small. Now, imagine that this tiny point has a weight of 10 suns. An object with so much mass compressed so tightly that nothing, not even light itself, can escape its grip would be like a grain of sand in the middle of your room, sucking all the furniture into it. It's no surprise that these objects have captured our imagination. But what exactly exists on the other side of a black hole? Believe it or not, what exists on the other side of a black hole is still a mystery. Many people imagine black holes as magnificent portals to some other world or dimension, where they can go on adventures with wonderful people in lost worlds with dinosaurs and winged horses. Well, believe it or not, this idea is not as crazy as it sounds. We'll get into that later, but for now, let's understand what we know today. So, if you were to jump into a black hole, where would you end up? What exists on the other side of a black hole? Unfortunately, black holes don't actually lead anywhere. In fact, there's no hole at all. Black holes are celestial bodies of enormous masses with incomprehensibly strong gravitational fields. We're familiar with black things like asphalt or your favorite t-shirt from The Killers, "We Wish You a Merry Christmas" tour that you never wear, but black holes are not just that kind of black. They're black because even light, the fastest thing in the universe, gave up trying to escape their immense gravity. Imagine carrying an elephant on your shoulders, or worse, wearing an entire elephant like a suit. Now, let's stand up and go for a walk. That's what you would feel like if Earth's gravity was increased by a factor of 50. If we were to increase the strength of gravity around your couch to near black hole levels, we'd have to multiply it by billions of times more than you experienced when you stood up with an elephant on your back. There would be billions and billions of elephants in your backpack. So, if you jumped into a black hole on a winged horse with your Infinity Gauntlet maneuver, for those who know the most powerful weapon in the Marvel Comics universe, and your lightsaber, you would be instantly transformed into a carnival superhero and an extreme atom smasher. Your mass would be added to the black hole and you would be stretched like spaghetti before being sucked in, leaving a smudge mark. Just to be clear, you wouldn't be taken or teleported anywhere. You would simply be added to the black hole. It's like thinking about a place you'll go if you jump into a trash compactor. If you jump into a black hole, your experience would be one of great angular discomfort and atomic disassembly. Here's the truly terrifying part. As time is distorted near the event horizon of a black hole, the universe around you would watch you approach the black hole more and more slowly. In theory, from the perspective of the universe, it would take an infinite amount of time for you to become part of the black hole. Even the photon reflecting your newly molded body could be stretched to the point where you become red and eventually just disappear. Now that we've cleared that up, let's consider this image of the gravitational field of a black hole. Anything with mass has a history. The more mass, the more distortion it causes in space-time. Black holes are responsible for the greatest distortions in the universe. Even with space-time distorted by the mass of a black hole, you can still draw a straight line through it. When you enter the event horizon of a black hole, all paths lead directly to the singularity, even if you are a beam of light. In other words, the information would not be lost inside the black hole, but rather preserved in some way and eventually released through radiation, known as Hawking radiation. This theory suggests that, when passing through the event horizon of a black hole, the person or object would not be destroyed, but would be transformed into a different form and emitted as Hawking radiation. This means that, in theory, it would be possible to walk through a black hole and emerge on the other side somewhere in the universe. However, this theory is still highly speculative and requires further studies and experiments to be proven. So far, there is no direct observational evidence confirming the existence of Hawking radiation or the wormhole theory, which suggests the existence of a tunnel through spacetime. While black holes are still a fascinating and frightening mystery for many, continued research in the area of theoretical physics may eventually lead to a deeper understanding of these objects and the possibility of exploring them in some way. Until then, exploration of the universe continues to fascinate and inspire the human imagination.